Okay, so today I'm going to show you how to make a folded mountain. So I've already pre-made my layers, and I have 4 layers. Obviously, in a real folded mountain, there wouldn't be just 4 layers. There'd be at least 6 or more. And so the first thing we have to do to make a folded mountain is to stack the layers on top of each other. Now, what we want to do is squeeze them together. So basically how a folded mountain is formed is when stress is put on the layers and they're kind of squeezed down and kind of lengthened down like this. So the next thing we have to do is basically the layers bend. And the main reason I'm using Play-Doh is so I can show you basically all the layers in basically the whole mountain. So basically this hill right here is called an anticline. And an anticline is when basically all the layers bend up. The middle part is called a syncline, and it's when all the layers move down or in a lower area. So basically it kind of looks like a McDonald's sign, I guess the way you could put it. So as you can see, there's still 4 layers and you can see them well, but there's a syncline and 2 anticlines to show 2 mountains in a deep either valley or just basin in between the 2 mountains.
Action.
Okay, so we're starting out with just a little tiny volcano, and we'll just pretend this is underwater for now. And so I'm going to make 2 more layers that are a little bit bigger than these 2 sides right here. So about this length. Right here. So I'm going to make 2 of these parallel to each other on the volcano. So before I put these down, we're just going to pretend we have an eruption. And so the eruption, since it's still underwater, causes 2 layers of molten lava to form because the water cools it. So as you can see, it's starting to get a little bigger. So we're going to make 2 more layers that are a little bigger than these 2 ones that I put on. And so we're going to put them parallel to each other again. So we're going to pretend we have another eruption, which makes this volcano still bigger. And so basically the thesis of this is that the more eruptions that happen to the volcano, the taller it gets, because like the huge volcanoes, such as like in Alaska and in the Ring of Fire, once they get to be so big, you can tell that they've had lots and lots of eruptions over their lifetime. And so as we keep putting these layers on, the bigger and bigger this volcano gets. So sooner or later, I think if I use all of this Play-Doh, it'll be, first of all, wider than this plate, and taller than the angle you're looking at this on. So basically I'm just going to put 2 more layers on, because it'll take an hour for me to do all of the other Play-Doh. So you could call this a huge volcano right now. But the thing is, it can't be extinct, because then that way it won't erupt anymore, and that's the same height it'll be for the rest of its life. So it has to be active to get this high, as long as there's more and more eruptions to bring it out of the water. So I have 2 rocks here. One's more triangular shaped and taller, and this is a shorter kind of trapezoid shape. And so basically we're going to connect the rocks like this, so we can just pretend they're a flat surface throughout a whole valley, the width of this plate. So basically there's a lot of compression, and this is already the beginning of a fault. So let's just say one of them faults and there's an earthquake. Now because there's other faults in the area, it'll start to shake and put more compression on the faults. So then this rock will go down and cause this to stay up. Like I said in the fold, there'd be a syncline and an anticline. So I guess in this valley between this rock and another one of these, you could call this a syncline, and these 2 would be anticlines because they're the mountains. So like I said, once this slides down, this is higher than the other areas. And because there's so many faults, it causes so many peaks in the area that you could call it a mountain range.